Right, part two. Say it's going to take some time making these bloody videos, but sure, we'll tip away like a wee dumper. The next type of calculation here is you're coming up with the empirical formula. So that's simplest whole number ratio formula. So like CH from like C to H2. Coming up with the empirical formula from data. So what I mean by from data is they tell you what percentage of each element is in a compound. So in this one here it says a compound's made up of 75% carbon, 25% hydrogen. What is its empirical formula? So the percentage really is no use to you. But what we're going to do is, and we're going to take this as if it's out of 100 grams. So we're going to say in that 100 gram compound, 75 grams of its carbon and 25 grams of its hydrogen. Now the reason we're doing that, because I know you know it, why do we want grams? We want grams because we can go back to moles. Think of a mole triangle, mass in grams, moles. How do we always go back to moles? We divide by the relative molecular mass if it's a compound, or divide by the mass number. So what we're going to do is find the number of moles of each of these. So work out the number of moles of carbon, say first. Makes no difference what you find first. So we're going to say 75 grams. To go back to moles divided by the mass number, which is 12. So on the calculator you get 25 over 4, or 6.25 moles. Now work out the number of moles of hydrogen. So there's 25 grams of it. So just change your percentage to the grams. Divided by the mass number is 1, 25 moles. So what that means is we've got C6.25H25. But if you look at your definition of an empirical formula, it indicates what elements are present in a compound, which it does, but in the simplest whole number ratio. They are not whole numbers. That 6.25 is not a whole number. So what you do then is, wee trick, like I would never write that down, divide by the smallest number of moles. So divide that by 6.25, divide that by 6.25. There we get 1. Here we're going to get 4. So now my empirical formula of this, C1 or CH4. So to recap, change the percentage to the grams, go back to moles, and divide by the smallest number, like a 3-step process. So the second one here, it says a compound consists of 68.85% carbon, 4.92% hydrogen, 26.23% oxygen. What is the empirical formula, the EF, of that compound? So go back to moles of each of these. So say your number of moles of carbon, 68.85 grams, divide that by 12, its mass number. And we get 5.7375, roughly we'll say 5.74 moles. Number of moles of hydrogen. This might actually be the nicest ones. 4.92 grams divided by the mass number is 1, so 4.92 moles. And then oxygen, number of moles of oxygen, 26.23 grams divided by the mass number of oxygen, the bigger number, which is 16. We get 1.64, see. Now divide each by the smallest. The smallest here is your 1.64, so divide that by 1.64, that by 1.64, that by 1.64. We get 1 there. 4.92 divided by 1.64, we're getting 3. Lovely. 5.74 divided by 1.64, we're getting 3.5. Yeah, this isn't the nicest for the second example, but sure. Put beef in your back. So at the minute we've got C 3.5 H3O1. Again, whole number ratio. How are we going to get these to whole numbers? We're going to double everything up. The reason we're doubling it is we're changing that there, 3.5 to a 7. Double everything, H6O2. So the simplest whole number ratio. I'll do another one with you, and then let you tip away it. Yes. It'll waken you up. Now, third example here. An oxide of carbon contains 27% Carbon, what is its empirical formula? And when it says an oxide of carbon, obviously it means that it's carbon and oxygen. And if we have 27% carbon, that must mean then there's 73% oxygen. You're 27 and you're 73, adding up to 100. So work out the number of moles of each. So the number of moles of carbon, change the percentage sign to a gram, 27 grams divided by the mass number, which is 12. 9/4 or 2.25 moles. Work out the number of moles of oxygen. 73 grams divided by the mass number 16. We get 4.56 moles divided by the smaller. Again, this isn't looking great. Thought of better examples. We get 1 here. Divide that by 2.25. And we get 2.02. Okay, that's perfect actually. So our empirical formula doesn't have to be exactly 2. Like 2.02, 2.1, 1.95, you know, bring it up to 2. Gives us CO2. Another one. And again, try these. Pause it. Try that there next example yourself. That's what we'll be doing in class. So here, this is what the compound consists of. Find the empirical formula. Change the percentage to grams. Work out the number of moles of each. So number of moles of sulfur. 23.7 grams divided by the mass number of sulfur is 32. You'll start enjoying them then. 0.74 moles. Number of moles of oxygen. So we have 23.7 grams divided by the mass number 16. 1.48 moles. Obviously that's going to be double it. Number of moles then of chlorine, and again chlorine, like copper, keep it in your half. 52.6 grams, divide that by 35.5. And we get 1.48, same as this. Now to get the whole number ratio, divide each by the smallest, which is 0.74. And we're going to get 1, 2, 2. So our empirical formula is S1O2Cl2. Marvellous. And one more. And then you can see in the bottom I've got the answers for the questions for you to try on page 178 of the notes, and the questions just in the notes. Don't look at them. Try them yourselves and see how you get on. Only did a few of them, I think. So here we've got various percentages. So the number of moles, change the percentage to the grams. So number of moles of magnesium, 9.8 grams divided by the mass number is 24. And we get 0.4083 or 41 moles. Number of moles of sulfur. It's 13. Divide that by 32. 0.41 again. And then the number of moles of oxygen. Oh, this is water, so it's a hydrated substance. Number of moles of oxygen, 26 grams. Divide that by 16. 1.625. And then the number of moles of water. So it's a hydrated substance. See what I mean at the end when I put it all together? We looked at the percentage of water in such and as such. You know, there. CuSO4.5H2O, there's hydrated substance, there's hydrated substance. So the number of moles of H2O, 51.2 grams. Divide that by 18. And we get 2.84. Same rules apply though, divide by the smallest. So 0.41. 0.41. 0.41, that's probably 4. .625. Divide that by 3.96, round that to 4. And I threw this one in just before and I got 7. So that means my empirical formula is Mg SO4 is like 6.93 or so, bring it up to 7 H2O. Now try the questions following up to that. There's your answers. Try them yourselves. First, go back over those examples and see how you get on.